In this video, we're going to be talking about the mirror equation, and the mirror equation is an equation which relates the focal length, object distance, and image distance of a spherical mirror. Okay, so it's an equation that relates the focal length, object distance, and image distance of a spherical mirror. Now, we will talk about the object distance. The object distance is simply the distance from the object to the mirror, and we represent it with this symbol U. Okay, the distance from the object to the mirror is the object distance. And then the image distance is the distance from the image to the mirror. We represent it with the letter V. Then focal length is the distance from the principal focus to the mirror. Represent it with letter small letter f or lowercase letter. So that equation that relates object distance, image distance, and focal length of a mirror is what we call the mirror equation. And mathematically it is given as 1 over f equals 1 over u plus 1 over v, where f is the focal length of the mirror. Don't forget, the focal length is the distance from the principal focus to the mirror. F is the focal length of the mirror. U is the object distance, that's from object to mirror, object distance. And then v is the image distance. So this is our formula for the mirror equation. Now, it's also very important to note that the focal length of a mirror is half the radius of curvature. Sometimes in some questions they will give you radius of curvature, and then they will expect you to calculate the focal length, which you're going to use in this equation. Now, you need to understand that the focal length is half the radius of curvature. That's to say, focal length is simply equal to radius of curvature over 2. This is your equation for focal length of a spherical mirror. Now, also, there are some very important sign conventions you need to know whenever you are using this mirror equation. Alright, aside knowing the equation 1 over f equals 1 over u plus 1 over v, there are some very important sign conventions you need to know in order to use them correctly. Now here it says, note, when the mirror equation is used in solving practical problems, it is important to add either a positive sign or negative sign to the focal length. Okay, it's important to add either a positive sign or a negative sign to the focal length, the object distance, or the image distance according to a sign rule or convention. When the mirror equation is used in solving practical problems, it is important to add either a positive sign or negative sign to the focal length, the object distance, or the image distance according to a sign rule or convention. That's to say, in this formula, we can have f to be positive or negative. We can have u to be positive or negative, and then we can have v to be positive or negative. It all depends on the rule. All right. What are these rules we are talking about? Number one, it says real objects and real images have a positive distance from the mirror. All right. That's to say, if you have a real object, they give you a question that they say the object is real, all right, or the image is real, their distance will be positive. All right. So that in that case, u is going to be positive if the object is real, and v is going to be positive if the image is real. Now, number two, virtual objects and images have a negative distance from the mirror. That is to say, if the image is virtual, its distance is going to be negative. So we are going to have minus v, the same thing with the object. Now, number three here says focal length of concave mirror, which is also a converging mirror, is usually positive. The focal length of a converging mirror or concave mirror is always positive. Focal length of convex mirror, which is a diverging mirror, is usually what? Negative. Alright, so these are the rules. Alright, very, very important rules. We apply them in solving problems. If you're given a question, they say it's a convex mirror, just know that the focal length is going to be negative. They give you a question, they say it's a concave mirror, focal length is going to be positive. Now, aside this, there's another important equation you need to know, which is the magnification formula. The magnification formula, alright, helps us to relate the image distance, object distance, height of image, and height of object. Now, according to magnification formula, we have here that magnification of a spherical mirror is the ratio of image distance to object distance. And mathematically, we have magnification equals v over u, where v is image distance, U is object distance. So we have image distance over object distance. We also have that magnification is equal to height of image over height of object. Height of image over height of object. All right. If they don't call it height of image, if it's not stated as height of image in your question, can be written as size of image. It's still the same thing as the height of image. All right. Size of image over size of object, or height of image over height of object. So this is the magnification formula. Now we are going to look at some practical examples. All right, let's solve some questions and then we'll see how this mirror equation alongside the sine rule and even the magnification formula is applied. Now in this question here, they said a man stands 50 cm from a concave mirror with radius of curvature 10 cm. Find the position of the image and magnification. A man stands 50 cm from a concave mirror. The man is the object. All right. So 50 cm from a concave mirror, that's the object to the mirror, is 50 cm. So it simply means object distance was given to us in this question. We have object distance to be equal to 50 cm. A man stands 50 cm from a concave mirror with radius of curvature 10 cm. So we also have radius of curvature given to us to be 10 cm. They say find the position of the image. So we are looking for image distance. All right, and then the magnification. All right, so which formula relates image distance, object distance, and radius of curvature? The reason why they give us radius of curvature here is to enable us calculate focal length, and we know that focal length is equal to half radius of curvature. So if radius of curvature is 10, we're going to have focal length to be 10 over 2, which is equal to 5 cm. So now we have image distance, object distance, and focal length. So it simply means we have to use our mirror equation, which is 1 over f equals 1 over u plus 1 over v. All right, f being the focal length, u being the object distance, and v being the image distance. Now, before we go on to solve, let's see if any parameter here is going to be positive or if anyone is going to be negative. Now, they said a man stands 50 cm from a concave mirror. Concave mirror is a converging mirror. Does it have positive focal length or negative focal length? It has a positive focal length. All right. According to our rule, concave mirror will always have a positive focal length. So take F to be positive. They say with a radius of curvature 10 cm. They say find the position of the image. We are looking for image distance for a concave mirror. All right. Now, they did not say that in the question, they did not mention to us that the image is going to be virtual. Besides, for a concave mirror, there is only one condition where we have a virtual image. All right, and that in that case, we are going to have our object distance being lesser than the focal length. That's when the object is located between the principal focus and the mirror. All right, but in this case, we have our object distance to be greater than the focal length. So it simply means this is not a case where we're going to have a virtual image. So we'll just go on and use our mirror equation to solve. I'll take it again. So if you look at concave mirror, there is only one case in concave mirror where you have a virtual image. And that's the case where the object distance is less than the focal length. In other words, the object is located between the principal focus and the mirror. All right, but in this case, we have the object distance greater than the focal length. So this is not a case for virtual image in concave mirror. All right, so this image is going to be a real image. So we don't bother ourselves. All right, we just solve like that. Okay, if it's going to be a virtual image, at the end of the day, we'll even see our answer to be negative because we're looking for the image position. So now let's go on to solve. We know that the focal length is going to be positive. We'll leave it that way. We don't put any sign attached to it. All right, because 1 over f is the same as positive 1 over f. So we'll go on to solve. Focal length is 5. We have 1 over 5 equals 1 over u. U is 50 plus 1 over v. We're looking for the image position. So now to make v separate of the formula, we move this to this side of the equation and we're going to have 1 over v left on the right hand side equals 1 over 5 minus 1 over 50. All right, and that will give us 1 over v equals, if we use our calculator to simplify this, 1 over 5 minus 1 over 50, 1 over 5 minus 1 over 50, that will give us 9 over 50. So we have 1 over v equals 9 over 50. Now what we need in this question is v, alright, not 1 over v. So to get v, we'll take inverse of both sides. So inverse of 1 over v becomes v over 1. Inverse of 9 over 50 becomes 50 over 9. Alright, so we have v over 1, which is v, equals 50 divided by 9. 50 divided by 9. That will give us 5.56 approximately. 5.56 cm. So this is the image position. Now the next part of the question says you should calculate magnification. Now we already know that magnification, as treated earlier, is equal to image distance over object distance. Now the image distance is 5.56 all over object distance, which is 50. We have all over 50. Right? If we divide this by 50, we're going to have magnification to be equal to 0.11. Alright, and magnification does not have any units. Okay, here you have cm dividing cm. Alright, 5.56 cm divided by 50 cm. Cm will cancel cm. Alright, so this is the magnification. So our answer is image position 5.56 cm and magnification 0.11. So that's option A. Now the next question says an object 3 cm high is placed 16 cm in front of a converging mirror. An object 3 cm high, so we have height of object to be equal to 3 cm, is placed 16 cm in front of a converging mirror. Alright, so this object of this height is placed 16 cm in front of a converging mirror. We have object distance to be 16 cm in front of a converging mirror so that it produces an image of 40 cm from the mirror. Alright, so we have image distance from the image to the mirror to be 40 cm. It said find the height of image, so we're looking for height of image. Alright, so now we know that these two are related by the magnification formula, which is m equals v over u. Also, height of object and height of image are related by the magnification formula. We have m equals height of image over height of object. This is magnification, this is magnification. Alright, so if m is equal to m, it simply means this will also be equal to this. So we're going to have v over u equals height of image all over height of object. Alright, and what's v? V is 40, so we're going to have 40 all over 16 equals height of image, which is unknown, over height of object, which is 3. We're looking for height of image, so we cross multiply. Alright, we're looking for hi, height of image. If we cross multiply, we're going to have 16 times hi, 16 times height of image equals 40 multiplied by 3. 40 multiplied by 3. Now to get the height of image, divide both sides by 16. So we have 16 times height of image equals 40 times 3. Alright. All over 16. Alright, all over 16. To get the height of image, we divide both sides by 16. So this is going to cancel this. Then we're going to have height of image to be equal to, we simplify this with our calculator, 40 times 3 all over 16. That will give us 7.5. So we have height of image to be 7.5 cm, which is option C. Now the next one here says the driving mirror of a car has radius of curvature to be 1 meter. So we have radius of curvature to be 1 meter. They say a vehicle behind the car A vehicle behind the car is 4 meters from the mirror. All right, so the vehicle is the object, all right, being viewed in the mirror. So we have object distance to be 4 meters. All right, the vehicle being viewed is the object. They say find the image distance behind the mirror. So we have image distance unknown. Now this is a question that involves a driving mirror. Now the driving mirror of a car is what type of mirror? It's a convex mirror. All right, do not forget, driving mirror is an example of a convex mirror. All right, and convex mirror usually has focal length to be negative. So in this question, we're going to have our focal length to be negative. All right, so now radius of curvature is already given to be 1 meter. Can get focal length, which is going to be 1 over 2. All right, radius of curvature divided by 2, and that will give us 0.5 meter. Okay, now we are talking about a driving mirror, which is a convex mirror. Don't forget the focal length will be negative, so we'll put minus here, negative. Image distance is what we are looking for. We are looking for the image distance. All right, this is a convex mirror, and convex mirror usually give rise to virtual image. So without even solving, we need to know that our answer here for V will be negative. All right, it's a virtual, it's a convex mirror, and it's going to give rise to a virtual image. All right, so now let's proceed and solve. Our mirror equation again is 1 over F equals 1 over U plus 1 over V. And F is minus 0.5, which is negative, so we have 1 over minus 0.5 equals 1 over U, which is 4, plus 1 over V. Now we need to get V. We make it subject of the formula. All right, this is minus 0.5. This is simply as positive 1 divided by negative 0.5. This is going to give us negative 1 over 0.1 over 0.5. Okay, now to get V, we'll make it subject of the formula. We'll move 1 over 4 to this side of the equation. We have minus 1 over 4 equals 1 over V. Now if we simplify, we're going to have 1 over V equals negative 1 over 0.5 minus 1 over 4. That will give us 1 divided by 0.5 minus 1 over 4. That will give us minus 9 over 4. So we have 1 over V equals minus 9 over 4. But our concern is V, not 1 over V. So we'll take inverse of both sides. Alright, so we have V over 1, alright, equals minus 4 over 9. V over 1 is V, and that will give us minus 4 over 9. Taking the inverse, which is minus 0.44. You can just leave it as minus 4 over 9 meter, alright, or convert it to decimal. Now this question says an object is placed in front of a convex mirror of focal length 10 cm. If the image is formed 8 cm from the mirror, calculate the object distance. Now question, let's try to bring out our parameters. Our question here says object is placed in front of a convex mirror of focal length 10 cm. So first we have the focal length given to us to be equal to 10 cm. Now this focal length, is it going to be positive or negative? This is a convex mirror. A convex mirror usually have their focal length to be negative, so we have minus 10. They said if the image is formed 8 cm from the mirror, so we have image distance to be equal to 8 cm. They say calculate the object distance if the image is formed 8 cm from the mirror. Now 8 cm is the image distance. This image distance, is it going to be positive or negative? Do not forget we are dealing with a convex mirror, and from the nature of images formed by convex mirror, we have that images formed by convex mirrors are always virtual. All right, images formed by convex mirror are always virtual. The nature of image formed by convex mirror is always the same. We have virtual, erect, and diminished. All right, VED. So since the image formed by a convex mirror is always virtual, it simply means this image distance of 8 cm, or this image will be a virtual image. All right, and it simply means since it's a virtual image, the image distance will be negative. So this is going to be minus 8. All right, so now we can use our mirror equation. 1 over f equals 1 over u plus 1 over v. F is minus 10, so we have 1 over minus 10 equals 1 over u, which is unknown, plus 1 over v. All right, v is minus 8, so we have 1 over minus 8. And that will give us plus divided by minus is minus, so we have minus 1 over 10 equals 1 over u, plus divided by minus is minus, so we have minus 1 over 8. All right, so if we proceed, we're going to have minus 1 over 10 equals 1 over u minus 1 over 8. If we make use of it of the formula, we're going to move this guy to this other side. We're going to have 1 over u equals minus 1 over 10 plus 1 over 8. All right, if we simplify, we're going to have 1 over u equals, using our calculator, we have minus 1 over 10 plus 1 over 8. And that will give us 1 over 40. So since we're looking for object distance, we'll take inverse of both sides. So we have u over 1 equals 40 over 1. U over 1 is u, so we have u equals 40 divided by 1, which is 40 cm. So that becomes our answer, which is option E. So with this, we have come to the end of this video. Please make sure you subscribe to this channel and also do well to like, drop a comment, and share this video to your friends.